I'm pleased to introduce Mr. Christopher Ling. Mr. Ling is an experienced expert who has written reports on more than 300 construction cases that amount to $500 million in claims and provided testimony in multiple mediations, arbitrations, and court appearances. As Principal of Architecture Forensics, Mr. Ling is responsible for all the litigation support through physical investigations, analysis, report writing, and expert testimony. He's analyzed all aspects of construction projects in order to support clients in resolving disputes and litigation. His leadership, knowledge, and experience and thorough analysis have been very effective in resolving construction disputes before litigation because he has the ability to explain complex designs and construction issues in a simple and clear manner. So with that being said, we look forward to a presentation on what for many of us will be a first look at an intriguing career niche in our AEC community. So with that, please welcome Mr. Ling.
So then after working construction, going to architecture school, I just did my internship doing residential architecture. Then I worked in larger firms doing schools construction, universities, and then high-rise residential. I went from a small architecture firm to a mid-sized firm to a large firm. I seemed to be pretty good at resolving issues. So when a lot of big change orders came up and there's potential lawsuits, maybe they'd sue the architect and the contractor would start, suing people. They'd always put me on that to resolve it. So I became kind of the fireman in some of the firms I was with, and I found out, well, I'm pretty good at doing this, and so now I just do forensics full time. So when I got into the forensic world and started to really see how the lawyers treat and think about contractors and architects, I really had a whole different opinion then of what I thought the standard of care was from my regular architectural job to the way attorneys see us. And that's when I said, I better go out and tell everybody. I better go out and let all these architects and all the people know that this is really how insurance companies see us and this is how attorneys see us. So that's what this presentation is about. One cool thing that I did is actually I was on House Hunters on HGTV. So my wife and my wife's a master gardener. I'm an architect, so they're like home and garden. We like that. And we bought a house in Vermont, so they said we don't go to Vermont very much. So we were on that. And if you Google ski condo versus lake house, the episode will come up. And there is some kind of forensic stuff in there that I find things wrong with the house and analyze it a little bit. But, forensic architecture. So forensics is just getting things prepared for court and debate. And, they're not architecture. We all know what that is here. But another thing I did, I was on, I'll see if this sound will play. I'm not sure. But I was on Inside Edition for the Barclay Center. There was an issue with people falling on each other. But let me see if this will, wait. Yeah, we're not getting any sound. Is there any way to get the sound? Anyway, what happens, I could probably voice over. Oh, all right. Sound's not playing. But I'll pause it at the important part. So they're building these stadiums steeper and steeper for the sight lines, and people are falling on top of the people in front of them. And that guy got, somebody fell on the back of that guy. They're hurting their neck, so a drunk guy walks by, and can't stand and falls on the people in front of them. And it's happening more and more because the steeper and steeper that they make this. And these two people fell on them. This is the center out in Washington State. Yeah, so here's the steepness as it gets steeper and steeper. Because they want the sight lines and they want to save the money and make it a smaller footprint and have more seats that are closer, so they have to go up and up and up. I'm going to stop it at 1. It's Lady Gaga. Then the Barclay Center was even steeper. So then it's just making a commentary about how it's steep and people are falling on each other, and there's a whole bunch of lawsuits being started on that. And then I say something. And then I'll say what I was saying, and I'll pause it. And they had some weird angles of right about here. All right, I think I stopped it there. So my commentary earlier was that as you have a seat in front of you, right? So you're walking by, and there's a seat down in front of you, and the higher this gets up, the higher, all of a sudden, if I'm walking here and I fall, I got my knee and my hip, I'm not gonna fall, and it goes down to your knee. At least maybe you can save with your knee. But then you see here, when it goes down to your ankle, it's just a tripping hazard. So now when you lose your balance, there's nothing to reach on to, and you just fall, and they keep on falling. And what they do is, when these patrons, it happens more than you know, because when the patrons fall, the center gives them tickets to like the next night or even season tickets to avoid a lawsuit, because they want to keep selling beer. That's where they're making all their money. They don't want these lawsuits to get out and then have to stop selling beer at these stadiums. So the reason I was bringing this up and showing this is because this is not a building code. So there's no building code that says the seat in front of you can't go too far down. There's no code for that. So this is something that's outside the code, and that's different than actually the standard of care. So the code's a minimum. And then the architects or whoever's designing this has to think what is safe in this instance and what's not. If this was a building that wasn't an auditorium, that kind of drop, you would need a railing there. So every seat would have a railing in front of it. Obviously, you can't have that, so the code allows in the stadiums that you don't have to have that railing. But it's up to the people designing them to say whether that's safe or not. I'll just skip to the next thing. But here's something, and there are ways of figuring this out. Just because it's not in the code doesn't mean there aren't resources. Doesn't mean you can't look into this and investigate it. And Architectural Graphic Standards has something like this spot right here. Am I on? So this one right here, and you still can't see it. Is this not working? There we go. So that one right there shows one person standing up against the wall and then one person walking by. And so that distance should be the distance or a suggested distance to actually look at and refer to if you're having somebody in a stadium that puts the seat up and stands to the side and lets somebody walk by them in an aisle. How far is that? And this stadium seating was shorter than that suggested piece. And if you have larger people and they're walking and they're drinking, it's just not a good scenario. And it's up to the architect and their standard of care not just to meet the minimum code. And some people say if you get a building permit, you've met your standard of care, is what people have said. I would never say that. But it's there's a lot that goes into the standard of care. The code starts it, and that's a minimum. And you have to go above that to make people safe. So in the Architect's Handbook, here's pretty much, this is a standard definition of the standard of care. So it's what reasonably prudent architect would do in the same community at the same time, facing the same or similar circumstances. So that's a general definition. And see, it has a location at the same in the same community. And so now we're more kind of like a global village. The more we implement model building codes, the more similar you'll be from state to state. Not every state has the same building code. So there is still some location factors. I'm working on a case in El Salvador. So El Salvador, doesn't have the same building codes we have here or the same standards. And one of the standards in their contract was to conform to the ADA code. The ADA is the Americans with Disabilities Act. That's a United States federal law. It's not a code. It's not a building code that has to be used in El Salvador. But it was in the contract, and so they had to meet that without really any inspectors or anything happening. So there's no reason they had to actually meet that. So you have to, adjust your judgment of architects based on location. 10 years ago in Pennsylvania, they didn't even adopt a building code for the state. It was only for cities. So I was doing a case out in the middle central Pennsylvania, and there was no building code, so they didn't have to meet any building code. And in fact, there were no inspectors or building inspections, and so it was kind of hard so the architect did his own inspections and got paid as a third-party inspector. So the way that the lawyers look at us is really from this court case. So the way lawyers look at the standard of care is based on case law. Case law meaning there wasn't a law about the architect's standard of care, but there was a lawsuit. And when they finished that lawsuit, the judge made a determination. And based on the judge's determination, that became case law about what the standard of care is. And so Spearin versus United States was actually a shipping yard in Boston. So in 1890, a designer was helping the U.S. Navy build a shipping yard. And the designer said, well, let's just cut out the pier, and here's the extents of the construction I want you to cut out. And so the contractor went in and cut it out. And it flooded the whole sewer system because they just cut way too far into things that they didn't know were there. And so there's a big lawsuit about it. Whose fault was this? Was it the contractor's fault for cutting into the sewer? Or was it the architect's or designer's fault for telling him to cut that far? And out of that, it came this quote here, which is that, I don't think I could recite it, but that the owner impliedly warrants that if the contractor follows the plans, it'll build the project that the owner wants. I think I paraphrased that. But so what that gave rise to, that definition gave rise to the way we really see the way construction works today. It's really the triangle that you've probably heard about, but the owner in a part of the triangle, the architect on one side or engineer, and then the contractor on the other, and you have that triangle of contracts, and that really starts from that early court case, and that's been going for all the AIA form contracts now have a form that's that standard. There's others, but that's the basic triangle of the contracts. So what happens if the code doesn't nicely fit into your design? So you could do a design like this, and then you have to look at it in terms of code and say, well, how does the code fit into this design? So they have this large handicap ramp and an amphitheater seating, and it goes alongside the amphitheater seating. And when it comes down to the sharp wedge here, so this part becomes problematic, the sharp point there, right? Because that looks like a little tripping hazard at the end. Someone's going to come up and just trip over that. So if you read this design from the code, then the first, when that lift is 0 to about 4 inches, that's considered a tripping hazard in the code. It's not a step yet. And then from 4 to 7 inches, I'm just guessing, that could be considered a step from 4 to 7 inches, although anyway, but that would be the size of a step, 4 to 7 inches. After that, from 7 inches to about 24 inches of rise, you wouldn't need a railing unless there were 2 steps getting onto that rise. So you don't then, by that definition, really need a railing across the top of this until it gets to the 24 inches. Then you would need a railing. But as you go down to this end here, now this is considered an amphitheater. So now, since it's an amphitheater, you don't need a railing anymore. So this is the problem with trying to take the codes and apply it. And again, when this happens, you need to really think about what's safe. So again, you might be able to interpret the codes and get away with it, but do you want to get away with it? Is it safe? You have to still go. The code's a minimum code, and you may be able to get away with it, but is it safe enough for your tastes? So a lot of times in drawings, you'll see the design intent. The intent of the contract documents, is to do it properly and do everything right. And it's kind of a catch-all phrase. It's just a phrase that you should put in drawings, but really doesn't mean all that much, because if you don't have something that's in the documents that the contractor's bidding on, then how is the contractor supposed to know what your design intent is? Now, there's a way. There's shop drawings, there's questions, there's RFIs. But the contractor is allowed to just bid on the drawings and specs that are in front of him. So if the contractor or if someone's interpreting plans, the plans may say to do this, and if you're looking at it, you might say, okay, well, that's what I'm going to do. Now, this looks like a development, and on a site plan, they may not have, anticipated the distance, and it looks like when you turn the corner, it is at street level, and they assumed it was flat, but obviously when it turned the corner, it was up high, and I guess somebody actually poured the concrete down here without, submitting an RFI. So here's another potential coordination issue on the left. If you're doing a plan on the inside of a bank, and you'll have a teller, and they'll say, oh, well, let's have an ATM, put the ATM at the end, and there it is, facing out. But if you don't coordinate that the stairs are 4 steps down and the sidewalk, then you'll have something like this happening. The one on the right, I don't know. I don't have an explanation. So they needed a certain amount of seats, and somebody did not anticipate that wall being there. So coordination, site plan versus, the site plan said, look, I need a 15-foot light, and the architect said, I want a walkway there, and nobody kind of figured out the heights, I guess. And there is something, there's coordination, there's a thing called ready check. Architects do have quality control and quality assurance. They don't have to redo the plans of engineers, but they need to look at them and coordinate them with all the other plans. So if you have a little fan symbol on your drawing and you have a little projector symbol on your drawings, they don't conflict in the drawing. But once you put the fan in with the blades, then it might conflict. So this is a potentially example of design coordination. I think the bridge one's fake, right? That one looks fake to me. I don't think they would actually do that. I'm not sure. The other one with the facade, I guess in a flat facade that would actually work, but I'm not sure what happened there. So I had a case in Texas when I got a call and a lawyer said, I have a case. The ice is not melting in an ice rink in a Texas mall. And I said, well, why are you calling me? I'm in New Jersey. So I told him I never did a hockey rink, never did a skating rink, I never did a mall. So you should go find somebody else. But if you can't find anybody else, I don't know if you'll find an expert who has done an ice rink in a mall before, right? So I'm like, I don't know if you'll find anybody, but if you do, use them. But if not, give me a call back. Called me back in 2 weeks. He said, I can't find anybody. There's 2 experts who have done this, and they're hired by the other people on the team. So I was hired by the mechanical contractor who was a sub in all this, and he was just providing the refrigeration to the ice rink. And so that's who hired me, a mechanical contractor. And so I came on late in the game. He wasn't the main focus of the lawsuit. I came on late. I read all the other expert reports, and there was the foremost expert on hockey rinks. And he got deposed. He had this excellent report. It spelled everything out. I read through his report and just started going through. He had all these equations for tonnage of cooling, and I just started going through all of his line items and doing the calculations right along with him, and he was explaining it in his deposition. And he had a factor, and it was just a factor that goes into the formula. And so I was looking for that factor. I finally found the factor, and the factor was use this factor if you have a reflective ceiling that's less than 24 feet from the ice. That was the factor. So in the mall, you didn't have, and this isn't the actual picture. It was like this, but it had a black ceiling, and it had a food court next to it that produced heat. And all the other HVAC systems are all operating separately. So there's just a big airflow in there, and so it just wouldn't freeze because of that. And once I explained what design coordination is, that the designers have to do the design coordination amongst themselves to get the design right, and then what the construction coordination was, what the contractors have to do to coordinate themselves to get it built, because all the other expert reports said it was coordination. They each said it was coordination, 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 coordination. But they never defined what coordination was. So in my report, I defined what design coordination is, separate from construction coordination, and exactly what happened, and then everyone settled. Because then everyone could figure out, all the lawyers and insurance companies could figure out what happened and who was at fault. So then it settled right away. Quality control. So, you do steps, and you do one floor, and you copy the steps, and you copy the next floor up, and you copy the next floor up, and you copy the next floor up. And if you go all the way to the top and forget to delete that top run of stairs, then somebody might actually build that top run of stairs. If you don't do proper quality control, check your work. And that stair in plan, that door that's hanging, in midair, in plan, if you don't know if you're looking at the stairs in plan and you don't know which is up or down, and you think you need a door and you pop it in and you don't check, you think about it in 3D, you might put a door like that on the wrong side. The quality control, check your drawings. So So when you're judging and looking at drawings and checking for standards, you have to know what your drawings are for. So you can have a set of biddable drawings that are not really ready for construction. And you can have a biddable set that's really not even ready for permits. So you could have a biddable set, you could have a permittable set that's there for permits, maybe not bidding, maybe not construction. And you have to determine and know what set your client's asking you for and what your next deadline is and what you're submitting this for. So there's biddable, permittable, buildable. And then after the architect does the buildable set, do we build with that one? No. So then we have shop drawings, and I'm talking about like a bigger commercial type building, right? So you have shop drawings, and then the contractors, if it's big enough, will do their own coordination set. They'll start with the structural, the foundations, the steel, and the contractors will take the set and submit it to all the contractors and not share it with the designer. And that happens a lot. So then there's a coordination drawing that the contractors do about where they're putting all of their stuff. And that's the set they build by, not by any of the sets that the architects do. But it is, building a building is truly a team effort, right? And that's why you can tell there's many iterations of design, and then there's even iterations of the drawings that the contractors do to actually build the building. So you can build it all together and do it all right. And if there's problems, often you've made the problem all together. The designers, the contractors, maybe the owners, local officials. So it's important to talk about design versus means and methods. So this is my example of, it's easy to design and draw a ship in a bottle, right? So you can draw a ship, you can put a line around it, it's a ship in a bottle, very easy to draw. But that's design, and then what are the means and methods to build that? Means and methods are usually what we say the contractors are responsible for all the means and methods. So this would be the means and methods. How are you actually going to build it? Now, if you submit drawings with your magic sauce, you want the ship in the bottle, contractors may bid and say, well, that's easy. I'll cut the back off. I'll caulk it back together. I'll silicone it. And that's the way I bid on it. But you've lost the magic there, haven't you? So, and that kind of example happens, not like that. But I mean, it happens that we do magic. The architects have certain magic they want to do, and it might not be bid out the same way that we intended. So also, architects and engineers, we build the building as complete. We don't show a hole on the drawings as a set of drawings of a hole, right? We don't draw the hole. We just draw the building in its complete form, not as it's being built, how it's being built. So you can draw it in its complete form with the footings and foundations in it, but what actually happens, you gotta dig the hole, right? So here, weren't proper precautions taken to stop that river from flooding the whole foundation. So I wanted to cover a few just things that you guys might use out in the field for inspection techniques and technology. So drones are big. I would encourage you guys, if you're interested in drones, it's very quick and easy to do roof inspections now, because you can throw the drone up. That chimney would have taken me a ladder, put the ladder up, and then brought a ladder up the ladder to get up on the roof to the top of that chimney to look down and see the water ponding. And no one would have found that, because I don't think anybody would have done that. We threw the drone up and flew this whole association, and all of the chimneys had water ponding on it. And a lot of the owners were complaining about water just underneath that chimney. So it was getting into the false chimney, and there was no flashing, wasn't properly built, and it was getting into the master bedroom. So drones are great now for quick inspections of buildings, getting up high. It's a lot safer to put the drone up than to put the two ladders up on the roof. You can get up high. This roof didn't even allow us to get a 40-foot ladder. We had to go get a lift to go up there. So instead, we got the drone and flew the drone over it, and we saw all the water ponding at the edges. I think this is So we just checked all of these flat roofs, and there was water ponding all over it because of the way the flashing was done. And then I had a claim in Ohio, in Cleveland, Ohio, and to do the inspection, we had to get me out there, a material scientist out there, to go do the physical inspection, but instead we sent the drone pilot out there and had him fly the whole building with a live feed. So the material scientist and I were sitting in our office, and we were just getting the live feed. So we're on the phone with the drone pilot, say, "Oh, go back to that one. Let's, go back, go left, go right." And so we saved, a lot of money by not having to fly. Both of us out there, the hotels, the eating, all that stuff. And the drone inspections, it was a facade that was cracking, and there was lawsuits about the whole facade. And so we were able to get 10 feet from that very quickly, just flying around that and seeing what's wrong. It still doesn't beat an actual physical investigation. We have to go back to actually take a few of these off. But to do a quick inspection of the whole thing, the drone was excellent. Infrared. So infrared's a great tool as well. I love using the infrared. When you look at a building in infrared, you could see. Hello. So you could see the studs. You could see the bays in between the studs. All right. So the studs are the green ones, and the bays in between. And then this bay here had a different heat signature. So we're really just looking at heat. So the studs, the green studs, are allowing the cooling to translate through the wall. The red is potentially insulation. So that one bay, that was strange that we wouldn't have seen, we wouldn't have found, wouldn't have even looked for it. But when we did open that up, it just didn't have insulation in it at all. So it was just missing insulation. So this is a great tool to just kind of see through the walls and see how things are built. And this one, visible light, when you looked at the soffit, there were some leaks around this window, but not in that spot. But the infrared picked up the leak above that without seeing the water or any staining on the inside. So we cut a bunch of that stuff up and fixed that there. So this is a case that went horribly wrong. No, not horribly. I mean, no one died, but it was a developer developing a condo building in New Jersey, and they wanted to build it, and I call it the developer's paradigm. You want to build it as quickly and cheaply as you can, and you want to sell it for as much money as you can. That's business, right? And when you go that tightly with the minimum codes and cheap as you can and as quick as you can, there's no room for error, right? So if you make one error somewhere, it could be a really bad error. So in this case, they designed it as a non-combustible building, concrete, steel, rated. They value, I'll get into that, but then they ended up putting wood in it, and then I'll tell you why in a minute. And then during construction, they tried to change it to a type 3 building, which is masonry, which is a hybrid, combustible, non-combustible, so masonry exterior walls and wood on the inside floors. And they didn't even build that right because they were trying to adjust and change as they were building it. And so if you really looked at the building, it's just like a 5A, which is just like any house, just like a wood frame house. And a lot of people living in there. So if there was a fire, it would just burn that whole place down. They wouldn't be able to stop it. It would happen too fast. And the reason you have the non-combustible on the bigger buildings is so if there is a fire, let's say in a unit, and that unit has an hour or 2 hour fire rating, then the firemen potentially can come in and put that fire out before it starts burning all the neighbors' houses down and the whole building. And the strange thing, actually, that up the road from there, about 2 years before, a whole building did burn down. somebody was soldering. It wasn't this building, wasn't the builder even. It was totally different. But they were soldering in the wall, and they caught the stud and the wall on fire, and the fire stayed in the interstitial space, between the sheetrock. So it didn't come out and hit a smoke detector. So the fire alarm didn't go off because it wasn't in the regular space. It was in the walls and ceilings. So once it actually got out, the whole thing burned down. No one died, but the whole thing burned down. So what happened with this one, the Grandview 1 case, is that they value engineered the floor system. So it was supposed to be a Hambro system, which just means that they put wood in the concrete form. They pour the concrete floor. Then they take the wood out once the concrete dried. Then they use that wood for the next form. They do the next floor and the next floor. So in the end, it's concrete and there's no wood left. So the developer was trying to make this building cheaper and lighter. And so somehow they came up with the idea that we could use less concrete in the floor if we put 2 layers of plywood. So 2 layers of plywood, and then we have less concrete. And that's going to save a lot of money, make it lighter and cheaper. So they told the designers to do that. The designers never really checked back with the whole code thing. They just kind of was at the end of the project, let's just value engineer this and give me final drawings. They made the change, gave it to them. And when they got to the site, so a project architect went to the site, and this is a Google Earth about the time when he went to the site, a little bit after, there was just massive amounts of wood all over, and the senior architect said, what is going on here? This is a non-combustible building. What's all this wood doing? He didn't know. So the senior architect didn't know. And then we have communications and emails that the developer said, I don't care, put your carrier on notice. We're going to keep on working with the construction. And they said, it's time to use our political capital with the town to try to get this approved. And the architect says, I want to meet with the local building code official. And the developer said, nope, you are not allowed to meet with the local building code official. We're going to do it. And there's no record of the meeting. And the building code official at that time, after that, he was charged with taking bribes, and he went to jail. And he was taking bribes within that time period that this happened. But in court, we couldn't use that. We couldn't say that because we couldn't prove it was a bribe in this case. We could only prove he was in jail and was a bribe for all the other cases. So the jury still kind of saw through it. In court, I had to prove, even though we knew there was wood in there, we still had to prove it to the court. They would just kind of deny it and say it wasn't there. So we had to do a lot of test cuts. We had to open it up. We had to show the wood and show all this to the court and the jury. And I was on trial for 2 weeks with the jury and did a wall section in 3D. It's really hard. So jurors, they don't understand, that it's hard for them to understand these things. In a 2-week trial to understand all about architecture and all about construction. So I actually brought in a metal stud and a wood stud and a block wall, to explain the difference between the 3 things. Start very simply. So the jury saw through that. They awarded about $24 million actually, and they got more than that. The code issue, there was $1 million from the architect because the architect did find it and try to stop it, and the developer wouldn't let him change. So they took it easy on the architect. But they got the developer for fraud, which means you triple the damages. So they said $3 million to the developer, but because you did fraud, you pay $9 million, and you pay all the other attorney's fees, which are another couple million. And there was other geotechnical settlement issues. But then they appealed. So they appealed this, and I was quoted in the appeal. So the panel of judges read all the testimony, and they quoted me saying, fire doesn't care about a waiver. Because the other attorney was trying to get me to say, couldn't you just get a waiver from the code? So I'm like, this building doesn't meet the code. And so, yeah, well, you can just get a waiver. You can just go to the local official and ask him for a waiver, and you can get a waiver from the code. And I said, the owners don't want a waiver, and the fire doesn't care if you have a waiver or not. So they quoted me on that, and they upheld it and awarded them all the money. Yeah.
So if this ended up being a type 5A building, all the wood was most probably enclosed with a 1-hour fire rated drywall, right? Did they at least do that?
Yeah.
Make it compliant with 5A?
Yes.
So everything had a 1-hour
It was
fire.
still, if you go back to the picture in the beginning, it was a 6-story building. So it still wouldn't meet, even 5A doesn't meet. Well, that was part of the lawsuit. They were like, well, what else can we do? I was like, well, you could take a story off, but those people probably wouldn't like it. You can. So in the lawsuit, I said you have to reskin the whole building and actually do a solid masonry wall on the whole outside. That's what it was in the court case. And they gave them the money, and so I'm actually trying to help them resolve it right now. And so I did go to the town and try to negotiate for an equivalency. And so I really explained how a 2-hour wall is for the notification that there's a fire, for the firemen to react, to get to the building, and then to go and try to save people or do something. So I broke down that 2 hours to actually what is the actual time, the equivalency of that 2 hours. So we did a better fire alarm system to the fire department, which was really right across the street, and it's a full-time fire department. It's not a volunteer. So they are actually there very quickly, and there's been false alarms, and they're there. They could see the building right from where they are. So they made us do a generator, upgrade sprinkler system, upgrade the fire alarm system, and they felt that that was an equivalency to the 2 hours. And we're starting to do that work now. Another case is a facade collapse. So this is an example of, there was one architect that had a canopy. Another architect came, put something on top of that other architect's canopy, some years later. And then a third architect came on and did some stucco on the front, attaching to the last canopy, which is attaching to the canopy before that. And so the whole thing fell down because they never really identified what was underneath and what the attachment was underneath. So when we actually examined this and all the connections, it was upside down, it was tangled, it was really hard, but I had to say, okay, that's the metal stud to metal stud with a good screw. Okay, it looks good. And then a metal stud frame here, good, that's good. And then like a little nail into a coping. And then I'm like, well, what was the coping attached to? And you look at the top, and there's just coping with like a wood nailer strip. It wasn't even nailed in the same spot. So there was like caulk and tar and little masonry nails actually holding all this together. The other thing that happened was that when the contractor built it, they did not. This was the third architect's design, adding on to the first canopy. Here's the first canopy was here. Then they added this on. And in the construction, they did not put this tie back on. So it was just fastened right to the coping, the old coping. And just a little bit of wind and water, getting in there, just fell. Luckily, no one died. It was in the morning. It's a coffee shop and a nail salon, and people were coming in and out, and it fell on all the cars because it was a strip mall. So the facade fell on all the cars, but didn't hit anybody. When you do get out in the real world, what are some of the common reasons why architects are sued, or lawsuits start? It doesn't necessarily have to just be the architect. But architects get sued for errors and omissions. There could be incorrect measurements. I'm working on a case right now that was $123 million cost overrun. and the architect did not measure the big renovation in New York City, and the architect didn't properly measure and investigate the existing building. So you can kind of put blinders on and say, well, I don't know what's above the ceiling, and I don't know what's in these columns, and you could sort of ignore that. But to be prudent about it, you should say, I want to cut some of these open. I want to verify what's in there. Is it steel? Is it mechanical? Is it ductwork? Is it pipes? So, not knowing the code, bad details, educating and communicating with the owner, that could just cause it. It is up to architects and contractors to talk to the owners and say what to expect, set your expectations properly, educate them as much as you can. Delays are a lot are actually not even on here. Building envelope is the biggest. If there's leaking and water leaking, that's going to lead to a lawsuit. And there's things to rely on. So you could rely on, there's documents. I think the AIA handbook, I don't represent the AIA or anything. I think the AIA handbook's great, the handbook of professional practice. I use that all the time. I used it when I was an architect and referred to it and referred to a lot of things. They have contract documents, form contracts. They have a lot of those resources that are great. And one of the architectural translations is, master builder, chief builder, principal craftsman, what an architect was way back when, and you may have done all those things, and architects can do all those things, but it's become so specialized that you have now, an architect doesn't do all those things. They do some things, they can do all the things. But now you have building envelope consultant, separate people, not necessarily architects or engineers, usually architects, but could be a non-professional, but just somebody who's good at that, or the manufacturer, roofing consultant, window consultant. There's so many consultants that can help you with any part of the building that you don't know about, you're not aware of, you're unsure, you don't know about. You can call the manufacturer, they'll come teach you. You can get a consultant on the board, on the team if you need it. Same thing with during construction. So, by the way, I guess all of these, on the right are all potential future jobs that any of you could do. I mean, I know people who are spec writers, roof consultants. I know people who just do these things, sign consultant, hardware consultant, theater consultant. I mean, there's a lot of specialty that you can do in this field, and you can start from any level. There's plenty of just contractor up people that do all of this stuff. Same thing, kind of during construction, a lot of this. Schedulers. I know a lot of people that just make a lot of money just doing scheduling and a lot of money just doing cost estimating. So these are just a little piece of what the whole world of design is that anybody could do. Code consultants, inspectors. So, I mean, I think architects are good at the big picture, though. So even if you have all these consultants, you kind of need somebody to put it all together. That's why, we're considered sometimes the conductor or the doctor. They consider you. You don't have to know how to play the flute. You just have to know how it works in the big composition of what you're doing. So, so you could be a generalist, know a little bit about all of that stuff, but maybe not be an expert in every one of those. And so there's a lot that goes into that. There's a lot that goes into, the creative mind of the architect or builder or engineer. There's a lot of resources you can rely on, a lot of books a lot of certifications you can get, a lot of books you can reference. And so that's it.